Hey everybody, welcome back to 6th grade science e-learning style. This is episode 3. Oh, come on. I'm just kidding. I'm awake. The plan for today's show, we're going to take a quick look at our previous 2 assignments, focus on some key ideas from those, discuss a little bit more about the Earth's movement around the sun through space, and then preview our work for the next 48 hours. Before we get down to business, though, I would like to learn more about you and what you've been up to over the last almost 2 weeks now. So I have 2 questions for you. I'm going to ask them. You have to answer. If you don't answer, I will not hear you. So please talk back to your computer and your iPad. Both of today's questions deal with food. Specifically, question number 1, I'm interested to learn what have you been enjoying in terms of snacks or meals over the last 10 days or so. What's good? I'm looking for a few tips. So what have you been eating that's delish? Yep. That sounds good. Yep. And surprisingly healthy too. A logical second question, what have you missed the most in terms of food or cuisine, not counting the ice cream from the lunchroom? What foods do you really miss eating? Uh-huh. Yep. Uh-huh. Mm-hmm. 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 Yeah. The list goes on. I can't believe you said bean dip also. We're like twins. Anyway, that was a lot of cheese balls. Let's get the show on the road and get down to business. All right, to begin, let's take a quick look at the 4 maps where we identified fronts, starting with the map of Japan. Japan indeed had a stationary front right here and also here, and the large capital red L's indicated areas of low pressure. The map of Mexico featured a cold front here, and these large capital blue H's are areas of high pressure. The Northeast Europe map had a couple of things going on. We had a large cold front there, and an occluded front. It's hard to tell that these are alternating between semicircles and triangles, but they are purple and they're facing the same direction. So we know that's an occluded front. And all of these numbers represented different degrees of air pressure, ranging from kind of high pressure near the capital H, all the way down to low pressure, the capital L. Lastly, the U.S. Northwest had a cold front approaching California, a warm front there, and then a stationary front there. MB, these numbers, the units for all these numbers, MB stands for millibars, not megabytes. Our other assignment was to do some research about Earth. Look how lovely it is. So let's look at some of those answers. Question number 1 asked about the line that divides Earth into a northern and southern hemisphere. Most of you answered correctly. Survey says equator. That's right. All of your second grade teachers would be very proud. The next question, fewer people answered correctly. There is a line that divides Earth into an eastern and western hemisphere. If you don't know this, just think of Indianapolis and the road that divides Indianapolis into an eastern and western part of the city. Nope, it's not Keystone. It is Meridian Street. So the line that divides Earth into east and west is the prime meridian. This question surprised many. During what month is the Earth closest to the sun? The correct answer is early January. So in early January, we are approximately 91.4 million miles from the sun. However, it tends to be cold in the northern hemisphere in early January. The next question, logically, 6 months later, we would be the farthest from the sun, which is early July. We reach about 94.5 million miles from the sun. Yet it's very toasty in the northern hemisphere. Curious. Let's talk about that later. How long does it take Earth to make one revolution around the sun? If you said 1 year or 365 days, that was close, but not precise enough. It was 365.25 days, which explains leap years. Every 4 years, those quarter days add up to a full day. How long does it take Earth to make one rotation around its own axis? 24 hours is one day in terms of our clocks, but in terms of one full rotation, it's actually 23 hours, 56 minutes, and 4 seconds. Earth's circumference at the equator in miles, good Googling on this one, it is about 24,901 miles in terms of all the way around Earth's equator. And how far does Earth travel around the sun to complete one orbit? Many people answered with these numbers or an average of these numbers. So what you provided was the radius of the orbit, not necessarily the circumference. We were looking for the circumference, which is 584 million miles, is how far Earth travels every year around the sun. The bonus question, if you're just seated in a chair for 30 minutes, how far are you moving thanks to the Earth's movement? Well, we know that if the Earth is spinning, this is the Earth's circumference, so in one day, that would be about the Earth's speed. So in 1 hour, it's moving about 1,000 miles. We're talking about 30 minutes, though, so it's half of that, 519. And then in a year, the Earth travels this far. Let's divide it by 365 to see how far Earth is traveling in a day. Divide that by 24, and then divide that by 2 to come up with this number, which is how far the Earth is traveling in about 30 minutes. So add those two together, and if you answered that correctly as your challenge answer, then you get a pony. All right, let's spend a little bit more time talking about Earth and specifically Earth's movement through space. So here we go. One key point, as you know, Earth is spinning. It's rotating around its own imaginary line, which is called the axis of rotation. Hugely important, though, this axis is not vertical. It's not straight up and down. It is tilted at a degree of about 23.5 degrees, and that tilt is stable. This has significant implications for us humans on Earth, because it means that as Earth is revolving around the sun, the tilt of the axis remains constant. So there are times where the northern hemisphere is tilted away from the sun, and then there are other parts of the year where the northern hemisphere is tilted towards the sun. Let's take a look at a few key dates during this trip around the sun. That'll be the sun. This is not to scale. The Earth, again, tilted axis, and this is an oval or ellipse, the sun, where the Earth does not move in a circle around the sun. When the northern hemisphere is tilted away from the sun, that is winter. And the date that kicks off winter is called the winter solstice. It occurs about approximately December 21st or 22nd, depending on whether or not it's a leap year. Some people call it the shortest day of the year. It's actually just as long as every other day. But they mean we receive in the northern hemisphere less sunlight than normal, or more darkness than sunlight. So we have about 9 hours of daylight and about 15 hours of darkness in Indiana. 3 months later, we kick off spring with what is called the spring equinox. That occurs around March 20th or 21st, just happened. Equa means equal, nox in Latin means night. So that is a day where some parts of the Earth have equal day and night, about 12 hours of daylight, 12 hours of darkness. 3 months later, everybody's favorite season, summer, kicks off with another solstice, or the quote-unquote longest day in the year for the northern hemisphere. So in Indiana, we have approximately 15 hours of sunlight and about 9 hours of darkness. Again, that's around June 21st and 22nd. And then fast forward 3 months, and we experience another equinox, this time the autumnal or fall equinox, which is roughly September 22nd and 23rd. And then back to where we started. This chart is a quick summary of the information that we went over. We went over it very quickly, faster than we would in class, because this is a video, so you can always rewatch it and rewind. This information will be helpful when you're completing our first assignment of this week. This document is available for download on Canvas. You can snag it and throw it into Notability. And all you're going to do is you're going to write 3 letters in each of these 4 triangles. Each letter will be used once, except for the letter B, that'll be used twice. So it's kind of a matching exercise. This YouTube video, I'll send a link to this. It is much shorter than the current video you're watching and much better, and it should help you with this assignment. And with our second assignment of this week, I'm going to ask you to make a 30-second Flipgrid video focusing on rotation and revolution, and the directions for that will be in the Flipgrid link. To get a Flipgrid account, you do have to use your school email address. And you know what the hippo means. Oh, man. Sorry, I dozed off there. I bet you did too. Anyway, thanks for watching. A big thanks to Diet Dr. Pepper and Cheese Balls for sponsoring today's episode. Students, please keep the questions coming if there's any confusion about the concepts or about the specific details of assignments. And hang in there. Make today count.